Hi, this is our South City, and we're the Fighting Tigers. It's classified, so only you can see our presentation. I'm Whit.
I'm Maya.
And I'm Sammy.
Our virus is parainfluenza. The first step that parainfluenza takes to get into an epithelial cell is the landing. The virus lands on the sialic acid receptors of the epithelial cell. The keys of the virus have to fit the cell's locks. Otherwise, the virus won't let the cell won't let the virus in. The virus has to be disguised as a protein. The HN glycoprotein oversees this step. Next, the fusion protein fuses the viral envelope with the cell membrane. The nucleocapsid of the parainfluenza is then dropped inside the cytoplasm.
The first step of the multiplication of parainfluenza is making the mRNA. The mRNA is essentially the negative of the actual group of proteins. It is made in the nucleus. After the mRNA is made, it gets released and then gets caught by two ribosomes, a big one and a little one. The ribosomes then make the opposite of that, which is the same as the original strand of proteins. And the ribosomes can keep making more and more of these, and they get released to go infect other cells.
Okay, so the last step parainfluenza takes is the budding and release and then the spread of parainfluenza. So first it's the budding. The RNA needs to float to the edge of the epithelial cell's surface and then start to push through. But first it needs to cut or break some proteins that would hold the virus to the cell surface and not let it go. So after it's done that, it can just bud and go through. And while it's budding on the surface of the virus, it gets the more keys to go that would unlock other epithelial cells so that they can get in. And the infected cell continues to make more viruses for 3 to 16 days after the 1 to 4 days of infection. Okay, so we have an analogy for our parainfluenza, and that's a robber getting into a bank, making counterfeit money, and then the business going out of business. And so one summer night, a robber goes into a office, and this is no ordinary robber. This is a robber controlled by money, and he only has one desire. So these are pictures. 1A corresponds to the epithelial cell in the parainfluenza virus, and 2A corresponds to our robber in the office.
Okay, so once the criminal was in the office, he went to the safe and got some money out of it, and then he went to the copy machine and copied the money and cut it into strips and put it back in the safe and took the real money out. And then he quickly walked out of the building unseen.
Here are more pictures that correspond with that past slide. Next, the police were called to try and catch the criminal, except they didn't catch the criminal as he escaped through the back door of the office. Then the main headquarters of the company, which was the one that the criminal attacked or counterfeited, lost its reputation and almost went out of business. Meanwhile, the criminal's reputation went way up after the counterfeiting, and lots of other criminals wanted to work with him. He started a new criminal organization and went on to counterfeit many other companies.
These are the pictures of the criminal escaping and the police coming. So there's a close-up of the criminal, and then you can see to the side it's just him escaping.
These are more pictures of our models, which you have already seen in pictures.
So these are like the parts of the epithelial cell, then the analogy, and what function they hold, and what basically how we were able to connect them and decide what was what. So if you want to take a closer look, you can pause it.
This is our bibliography. We have lots of sites where we got pictures or diagrams or valuable information. So you can take a look.
And behind it in the picture, those are multiple types of parainfluenza because there's 4 types.
Thanks for listening. We're the Fighting Tigers. I'm Whit.
I'm Maya.
And I'm Sammy. Adios.